All right, the video for today is a combination of a couple different things in regards to angles. Then we'll move into triangles, and then we'll work with some different things. We've kind of already worked with triangles before this in regards to the Pythagorean theorem, so we know at least one triangle of the different types that we have. So the first part that we're going to talk about is angles. Angles are all around us, depending on the size, shape. That depends on the name that they're given for this. So when we look at angles, there's a couple different ways that we look at them and identify them. The first thing is there's two rays. They have the same end point or vertex. A vertex is simply where a point comes from, and it comes together. So a corner of a desk, the corner of a wall, where the wall meets the ceiling, different things like that would be considered a vertex. From that, the rays that you draw are extended outward from that direction, and they can continue on forever, which would have an arrow at the end of the drawing, or as segments, which would just be a finish line. There wouldn't be any arrow at the end of it. It would just stop. So the vertex must be the middle letter when you label the angles, and we'll get into that a little bit later. So be careful of that, especially when you label this. And there's a lot of different ways that you can label different things, and we'll kind of go through that as we talk in this video. A couple other things regarding labeling. You can label with 3 letters, or you can just label with 1. You can even label it with a number. So you can say angle ABC, B being the middle letter would be the one in the middle. That's the vertex. You could just label it angle B. Or angle 1, be very simplistic about it. So there's a lot of different ways, but in geometry you have to be very specific in how you label things and how you identify things when you work with them, when you answer questions or create something. So different angles that you see around, and hopefully this kind of is a review for you from previous years. You have different size angles, different directionality that you can make them. But what we're looking at is we're just looking at how are they identified. And that's again by the size of their angle. So some of the ones that we're going to talk about as we go through this, we're going to draw them up. I would suggest you draw some of these just so you have some examples. Label them. You can label them any way that you want. If you want, and I'll probably label them differently in this presentation. There's going to be a symbol that you use, which is kind of a simplistic or a smaller, what looks like an angle. So it's a smaller part, and then we just put the letters next to it. So again, ABC, A being or B being the middle point of this for your vertex. So the one thing that you may see in examples of angles is the little arc sign, which is the little black curve thing that you see in that angle, and that will be something you look for in when we get into triangles, of trying to find angles of triangles. So the way we say it is simply we say angle ABC. Now you can also flip the 2 letters A and C around, but you cannot flip B. B has to stay in the middle if that's the one that's identified as your vertex. But you can have angle ABC, angle CAB, so, or CBA, excuse me, for what you can write down. So as we go through this, these are the types of angles that we're going to have, and again, when we get into triangles, you'll notice that they'll probably come back to be able to identify the triangles that we're working with. So the first angle is a right angle. We kind of know this from the Pythagorean theorem section. It's an angle that equals 90 degrees. So think of a corner of a wall, or where the ceiling meets the wall, sort of like that. When you draw it up, it's going to look like a corner, or at the bottom where the floor and the wall meet. One of the things that we look for is in geometry is, do we label it properly? And as we label it, we notice that in this case our C is our vertex, so that C is going to have to be in the middle, or we can just label it angle C. So when we look at doing this, the symbol for this is the little box in the corner, and that identifies it as a right angle for what we're dealing with. And then we just say it's a right angle ACB, or we can say right angle BCA. So those are the 2 different ways that you can write a right angle. The second type, or here's some other examples of what you can, and again the orientation is going to create some issues but you have to make sure that you have a 90-degree angle. They do not necessarily have to give you the symbol for the right angle, so be careful with that as you're looking through them. Second one is an acute angle. It's less than 90 degrees, so anything up to 90 degrees. So the largest acute angle that you can have is 89 degrees. So here's an acute angle, here's an acute angle, and here's another one. So anything less than 90 degrees is considered an acute angle. And again, there's one that's getting close to 90, but it is not, and it's less than, so it would be considered an acute angle. So obtuse is our next one. As we look at it, now we're getting greater than 90, but less than 180 degrees. So we're looking at things that are larger than 90 degrees, but they are not a flat line. So we'll get to those in a little bit. So those are the different types of 180 degree, less than 180 degree, but greater than 90 angles that you'll have, and we call them obtuse. So examples, number one would be an acute angle. Just looking at it, it's less than 90 degrees. Number two would be a right angle. Number three would be an obtuse. Number four would be an obtuse. Number five, acute. And number six would be a right angle. So again, depending on the orientation, you got to be careful. But if you notice where the 90-degree angle is, if it's less than that, it's acute. If it's more than that, it's an obtuse. And if it's right at 90, we're looking at a right angle. So our last angle that we're going to deal with is a straight angle. Straight angles are 180 degrees. We call these generally lines. So it can look like a line. It can also look like a segment. If we don't have the arrows at the end of the line that we're drawing, a segment ends, a line goes on forever in both directions. So that takes care of this one in regards to our angles part. Our second half of the video today is going to be on triangles, just identifying triangles by their angles and by their sides. So triangle means, or tri means three. Angle, we've already discussed that, so you can go back and look in your notes in regards to that. A triangle is a three-sided polygon. A polygon is a multi-sided object that we identified by its sides. And the one important part of this is that the sum of all the angles in a triangle will equal 180 degrees. So that's kind of an important piece right there as you go. How we identify triangles is a couple different ways. One is by sides, by what we call a scalene, an isosceles, and an equilateral. We also do it by angles, which we just identified, and that is acute, right, and obtuse. And again, one of the things that you want to recognize is that if you take a triangle and you cut it at one of the angles and you lay it flat, it'll equal 180 degrees or a straight line. And that's again why if you add up all three angles in a triangle, they equal 180 degrees. So if we do it by sides and we talk about a scalene, this is a side or a triangle that has no sides that are equal or congruent, and the word congruent is defined as the same size and same shape for what we're dealing with. So if we look at some examples of a scalene, you can see that we have no sides here being equal to each other in what we're looking for. The other one is isosceles. The word iso itself means two, so we're looking for two sides that are equal, that are congruent as well, and that's a geometry term that you'll be hearing a lot of as we go through this next couple sections. Isosceles, again, here we go looking at the triangles. We have these two sides here that are going to be identical to that. The last one is equilateral, and again the word equa comes from the word equal, so if it's an equilateral triangle, we're looking at all the sides of the triangle being equal or congruent. So in regards to what they look like, here you go. Again, you have all of the sides looking equal. And again, you can orientate your triangle any direction that you'd like. So you got to be careful with that in regards to the angles that you're looking for. If we're looking by angles, well, this should be kind of a review. All three angles must be less than 90 degrees. So an acute angle or acute triangle is anything less than 90 degrees. For a triangle, all three angles have to be less than 90 degrees. So here are some acute triangles that you're looking at. We also have a right triangle. Right triangle, one angle equals 90 degrees. The other two angles have to be acute, because if you had it anything larger, they wouldn't equal 180 degrees if you added up all three of them. So again, one of the things you look for is in a right triangle is, does it have the little square in the corner to identify it? They don't have to, but you got to be careful with that if they do and if they don't. The other one that we have is obtuse, and again, one angle must be larger than 90 degrees. The other two angles again will be acute. Again, all angles equal 180 degrees. So here's some obtuse. You're looking at something that's larger than 90. The other ones are going to be less than 90. So if we look at it by classification, you can identify them both by sides and by angles. So you could have an acute equilateral, so all sides are equal and all the angles are acute, less than 90 degrees. You can also have an obtuse scalene, which means you have one angle in the triangle that is larger than 180 and none of the sides equal. You can also have a right isosceles, so you have a 90-degree angle in your triangle and two of the sides are equal. So if we look at these, if we ask by angle, we're looking at the angles themselves. So we're looking where the vertices are. So we're looking here, in here, and we're looking at an acute triangle. For here, if we're looking just by sides, we're looking at do the sides of the triangles equal? And this would be no, so it would be a scalene triangle. For this one, you're asked for both, so it's side and angle. You're looking at an acute angle for all three, and you're probably looking at an isosceles. If you kind of look at it carefully enough, they both do equal. Here's a right angle, so an angled triangle would be a 90-degree or a right angle. For sides, they look all the same, so we're looking at an equilateral triangle. And then we have side and angle, and that's, again, we have one angle that's obtuse, it's greater than 90, and then the sides, it looks like these two sides here are the same. So that's our identification of triangles and angles. They kind of work together, and then we'll move into a little bit more of a concept later on.